Okay, you guys are about to embark on a qualitative analysis lab, your last lab of the year. And this is a chance for you guys to look at different physical and chemical properties that you've learned throughout the year, and you're going to use this to determine the identity of substances in the lab. Now, this process, it's going to be used to find unknown substances. It's based completely on observations. It has nothing to do with measurements and calculations. So that's something important to remember. You'll be able to separate these substances from one another, and then you're going to use some confirmatory tests to be able to figure out what each of those substances look like. And one of the first things you're going to be given is a known solution. And in this known solution, you are going to have 9 ions. Everybody are going to have these same 9 cations. And so it's going to be completely the same solution. You're going to go through and you're going to confirm the presence of each of these. And when you confirm the presence of them, you're physically going to take this information to your teacher. You're going to show your teacher what it looks like. Hey, I have this yellow precipitate, for example, in my test tube, so that confirms that I have the presence of lead. And so that's going to be part of the grading scheme, and we'll describe a little bit more in detail the grading scheme later on, but part of the grading is that you do confirm all 9 of these cations, and it's going to be your responsibility to go and take those to your teacher and show them to her. So after you get your known solution, you're going to have an unknown solution. Now, in your unknown solution, you're going to repeat exactly the same procedure that you just went through with your known, but you're not going to have 9 cations in there. Instead, you're just going to have 4 of those ions in there. Because it's the test grade portion, and I know we'll talk more about this grading later, but this is the test grade portion, you will not confirm the presence of each of these ions with your teacher. Instead, what you're going to do is you're going to go through this, and you and your partner, you're going to make sure that you really have gone through this lab thoroughly, you feel very confident with your results, and then you're going to present this to your teacher by just mentioning the names of the 4 ions. You'll probably write them down for your teacher at the very end, but you will not bring test tubes to them confirming the presence of those ions during the process of going through the lab. And then another part of this to remember is that this is your lab. This is not your teacher's lab. This is your lab. So a really important thing to do is to keep good records the whole way through. At no point should you rely on just your memory, because it's so easy to forget what step you're on or what might be in a certain test tube. And it's also possible for things to change their appearance overnight, so you really need to keep some good records. Do not rely on your partner. Don't expect your partner to be the one writing all of this stuff down. It needs to be you as well, so both people need to be responsible for that. And you should always be able to come back to your lab the next day and know where you stopped and where you need to start. So make good notes, take good notes. Both of you guys need to be able to do that. You also need to be able to look at your cup that has the test tubes in them and know exactly what is in each of those test tubes. All right, so you're going to get a cup, and in that cup are going to be 6 empty test tubes and 1 corked test tube, and in that corked test tube you will have a known solution. So one of the first things that you're going to need to do is be able to label all of this information. So your cup, you'll need to get a piece of paper. You'll have a piece of paper available for you. You'll need to write down both of y'all's names and your class period. You need to tape this paper to the cup, and then we'll go through a labeling process of our test tubes. So you're going to label the test tubes with a Sharpie. It's best to put it up high on the test tube because we're going to be using hot water baths, and they can get worn off and washed away pretty easily. So you're going to write it up high, but I do ask that you don't write it on the test tube itself where you've got that white or blue mark, because that cannot be erased. You want to make sure that you can have enough variety, you know, A, B, C, D might be how you go ahead and label these, but if you have them permanently listed on that white or that blue label, you might not get enough variety. You might have a few C's or something like that. So anyway, you're going to label your test tubes with the Sharpie, and you need to make sure that you start with clean test tubes. These have been reused throughout the years, so as you start this, make sure your test tubes are clean. Okay, so looking at our materials list, And for this, I'm looking at my lab itself. Hopefully you guys are following along. And I see under chemicals, there are 9 solutions of cations, or actually solutions of 9 cations, I guess is what it is. And this is going to be your known solution. For some reason, our picture is oriented a strange way here. But you can see that we've got a solution where we have 6 milliliters is what you're going to be given. Well, if you read through your lab, you see that you only need 2 milliliters. You don't need 6 milliliters, which means you're being given enough for 3 trials. You need to just take this and eyeball it because we're not doing any exact measurements. You're just going to pour off 2/3 into another test tube, or maybe just pour off 1/3 to use that. And then you're just going to work with 1/3 of that. In other words, 2 milliliters at a time. That's the amount that you'll work with. And you're going to be given, when you get to your unknown, you're going to be given the same amount. You'll start with your 6 milliliters again, but again, you'll only need to work with your 2 milliliters. So you can think of it as having extra there for a rainy day. So now when you go through this with your known solution, right, this is our known, this is going to allow us to understand and make note of what each of these cations look like. So that's going to give us the experience we need for when we get our unknown. Okay, still on our materials list, we see that we have some test reagents, and there are 12 of these. So the 12 test reagents, they're in labeled bottles. So if you were to look closely at these labels here, they say what station they're at, and they say what the solution is that's in there. So make sure that you are working only with the bottle that is for your station. If you run out, you let your teacher know, and she can refill it for you, but please do not just grab from another group station. Also, there is a 13th bottle in there, and that 13th bottle is for DI water. And the reason being, it's a lot easier to use a little dropper bottle like that when it refers to doing drops of DI water, as opposed to using a rinse bottle. We're not going to use the rinse bottle for adding drops to our test tube. And then the rest of our equipment, what you're going to do each day, you're going to go to the designated area where the cups are stored, and you're going to grab your cup that has the test tubes in it, and you're going to head to your station. So you'll have a station dedicated to your area of work. And each of these stations, you're going to see you've got a test tube rack to be able to do your work with. You're going to have your test reagents. Then you're also going to have a DI water bottle. Remember, when you run out of water here, it is your responsibility. This is sideways again. That's kind of funny. It is your responsibility to go and refill your water bottle from the DI water cooler. So do not just grab somebody else's. The other equipment that you're going to need some things like a centrifuge, a hot water bath, litmus paper, and I'll kind of discuss those things a little bit here in a bit. But on top of that, you'll need corks, test tubes, or test tube holder, and stir rod. These things might be at your station, or there might be a designated place in your room for you to just go and grab and then return them to that bin at the end of the period. So you will be able to use all of that information. Speaking of information, here we have some miscellaneous information. This is not written up in your lab anywhere, but some things to keep in mind. If you break a test tube, these are more expensive test tubes, so they're going to be 50 cents each if you break a test tube. We understand that it is a mistake. It's not something you're trying to do, but we need to reimburse ourselves for that. So 50 cents for broken test tubes. Please have change available if possible. And then glassware, that gets broken at times, so make sure you know how to dispose of that properly. Solution. You're given 6 milliliters of your known and 6 milliliters of your unknown. If that's not enough and you need more, it means you made too many mistakes, so it's going to cost you some points. Also, as you're going through this, make sure you get your partner's contact information. So it's really frustrating for somebody to be ready to work, but their partner's not there. Maybe they even gave their partner all of the information on their lab. That can be really frustrating. Remember, you should keep your own data as well. But get your partner's contact information so that you guys can stay in touch. Each person is allowed to work 1 day without their partner. And, of course, both partners need to be okay with this. But things come up, and I know there's going to be some absences, so you can work 1 day without your partner. If other instances come along and it's just not working out for the partners to work together, we can talk about some options there. And then there's also some other places where you could get some point deductions. I'm assuming everybody's going to start with 100 in all of these areas, but if you don't clean up your lab, you're going to get some points deducted. If you have lab violations, you're going to get some point deductions. Obviously, goggles are going to be worn throughout. That's going to be a huge part of this. If at any point you're back in the lab without your goggles on, it'll be point deductions and then, of course, some other possible repercussions as well. Okay, so now I'm following along in my lab where it's still on page 1, I guess, where we're starting with avoiding contamination. So this is just an upside-down picture that is showing us how we need to make sure that we don't have contamination enter our lab. This is going to be a great concern when you're working with your unknown, especially, because you don't want false positives. You don't want to get some sort of indication showing that you have some ions in your solution that you don't truly have in your solution. So some things that can lead to contamination would be things like tap water. So you can go ahead and wash your test tubes, wash your stir rods, all of that stuff at the sink, but be sure at the very end, make sure that you rinse with your DI water. So you always need to have a DI water rinse at the end. A lot of these test tube brushes are going to be pretty dirty, so just be careful. Again, you can wash with them, use them to scrub, but make sure you get that final rinse with DI water. And then stir rods, you're going to stir from one test tube to the other, so make sure that you do some sort of cleaning in between, either with a DI water bottle, or sometimes people like to get a paper towel, wet it down with some DI water, and then just wipe it and then move on. Okay, heating solutions. We are going to be working with hot water baths, and these hot water baths, we're going to have our test tubes in there. So it's going to be important for us to get those hot plates going as quickly as possible. So when you guys come in the room, please make sure that you go ahead and plug it in or turn it on, depending upon your hot plate type. But you can see in this picture, which again, we've got it sideways. We changed formats a little bit, and I guess it changed all the pictures. But you can see that we've got some test tubes in there, and they're heating up nicely. Well, this starts to evaporate pretty quickly as that water boils. So then we have it suddenly going dry, right? Well, if you try and add water to a hot, dry beaker, it's just going to break. So make sure that you never add water to a hot, dry beaker. Instead, you're going to have some refill water that's going to be available to you. And by refill water, it's just tap water. So you're going to have a container that's available for you, and you can just fill it up with tap water and add to it as needed. But you should never let a beaker, a hot water bath beaker, get less than halfway full. So you should always keep it with water in there. Okay, stirring solutions. When you stir these solutions, again, think about cross-contamination, and then also be really careful. It's pretty easy to get energetic with the stirring, and some of these test tubes have been around for a while, so it's pretty easy to break a hole in the bottom of them. And not only is that 50 cents, but it's just sad because you just lost all of your solution. Okay, separating solids from solutions. Well, that's what a centrifuge is for. And when you guys use a centrifuge, a couple things to remember. First of all, corks do not go into the centrifuge. You remove those from your test tubes first of all before you put them in. Then you also have to think about counterbalancing. If you just have one test tube with solution in it that needs to be centrifuged, you need to either find a friend or create another test tube with just some tap water in it of equal volume. And whichever situation that might be, and typically it's going to be trying to find another group that needs to centrifuge as well, you need to think about counterbalancing it. And what that means is you put that other test tube across the way from it. If you have 4 test tubes, it doesn't really matter. You could do those 4, but somehow you need to make it symmetrical. And the whole goal here is to just limit the vibrations of that centrifuge. If it starts vibrating too much, it can crack the test tubes, and nobody wants that. So when you guys use this, you get rid of the cork, you counterbalance, then you close the lid and you lock the lid. That's what makes it be able to turn on. It will not turn on unless that lid is latched. Remember, turn it to the right to tighten it, to the left to loosen it. Do not try and bring that knob all the way around because that'll break that lid. And then for turning it off and on, we're just using this timer switch, which I'd have to look at it closely, but I think it's like in minutes. We are not going to do it for that long, so all you have to do is physically just turn it to start it and then turn it the other way to turn it off. You're going to let things spin for about 30 seconds unless you're told otherwise in your lab. And here is the toughest part of all. This is where it is a test of patience, because you're going to stop that centrifuge, but then it's going to keep on spinning. And the rule is you never, ever, ever stop a moving centrifuge. You cannot put your hand in there and stop it. So really the easiest thing to do here is to keep that lid closed. Don't even try opening it because that'll be tempting to stop it with your hand. Occasionally what happens is breakage does occur in the centrifuge. So if that occurs, there are some ways that we can maybe salvage some of the solution out of the inserts. There are the little plastic inserts inside of the centrifuge that we can maybe salvage some of that solution out. So your teacher can help you with that. Okay, again, with the centrifuging, the reason we're doing this is so that we can separate our solids from our liquids. And what we're seeing is that you've got that solution, and through centrifugal force, it takes the solids and puts it down here, and you've got your liquids, your solution up on top. So when you go through this, for example, the very first thing you're going to do in your lab as you read through the procedure, you're going to see that you start with your 9 ions in solution. You're going to add some hydrochloric acid. It spells out specifically how much of this you're going to add and what you're going to do with stirring. Then you're ultimately going to centrifuge it. When you do this, you're going to get this, the chlorides are going to combine with lead ions, mercury ions, and silver ions. They are not soluble as chlorides. So they're going to form solids. They're going to form precipitates down at the bottom of your test tube. The rest of those ions are going to stay in solution up at the top, and that's referred to as the supernatant. So just to remind you that, and I'm going to bring this up later, but you have a flow chart there. Here we see all 9 of those ions. Quickly tells us add some acid, centrifuge. Yes, you get these 3 solids, and here we have the other 6 ions in solution. So be really careful as you read through your procedure. Quite often when you centrifuge something, you dispose of the solution or the supernatant on top. In this case, this would be a situation where you need to make sure you do not dispose of it, because you need this supernatant in order to test all of these ions in the upcoming steps. So I think that spells it out there. You know, another thing, I guess, about decanting this, you oftentimes have to, says to save the supernatant. You know, really that's just a matter of pouring off or decanting. So that's just putting it into another test tube for you to be able to work with later. Okay, so washing precipitates, sometimes this needs to happen, and your lab will tell you to wash a precipitate. So this ensures that the ions are removed from the precipitate. For example, what we just looked at, when you test for lead, you get these lead ions out of solution. Sometimes they can be hard to get out of solution, or out of, you know, they remain with the solid there. So what we do is we add some DI water, and I think it's somewhere, I forget, 12, 24 drops, somewhere in there, but it doesn't really matter exactly. You just add some DI water. You're going to stir it. I think this step, it might even tell you in the lab for this first step, it might tell you to heat it, but you wouldn't do that unless it specifically told you. So washing this precipitate, you just add your water, stir, centrifuge, and discard that wastewater. So that's in hopes of getting these lead ions out of this test tube. That's what you're trying to do, is rid yourself of that. Yes, it's usually DI water. Occasionally you'll be asked to wash your precipitate with something different than DI water, so just read your lab as you go through that. All right, upside down picture, here we go. This is completely off. This is our base, which is blue, and this is our acid, which is red. Okay, so that's the acid. And what you're going to be doing here, at times you'll be asked to double check the pH, and we have to be really careful about conserving the pH paper because we can go through it pretty quickly. And chances are it'll be somewhere near your teacher's desk, because otherwise if we keep it out in the lab it gets really gross and can't be used again, you know, grubby fingers kind of grabbing at it or just having a solution spill on it. So the way you're going to work through this is you only need to grab one strip at a time, and you just put that strip down, and you take your you take your stir rod, dip it in your solution, and just touch that the litmus paper and see what color it changes. So you will be able to use that strip multiple times. Okay, we also need to worry about storing solutions. And with storing solutions, you're going to have to keep an eye on the time as you work through this. So try and think about good stopping points in your lab. You're always going to want to try and stop at the end of a step. Don't begin a step and then not follow through after heating. So when you store this, you cork your solutions. If you have any solutions, just put a cork on them. And if you've got a precipitate that's present, then go ahead and add a few drops of DI water before corking it, and then go ahead and place the test tubes in a cup, and you're just going to store those in the designated area. Okay, you'll also have to worry about disposal of solutions. A lot of these things can really go down the drain, but we're trying to just be as good as possible about trying to get as much waste in the filter paper as possible. So there's some solids, some precipitates that we really want to try not to get down the drain. And those are listed there in your lab. But really, you can think about any solid that you come across. Try and get that into the filter paper as much as possible. The way you can do this, you can just go ahead and dump into the filter paper, squeeze a little bit of water into the test tube, rinse it around, and then try and get it in there again. The rest of it can just be washed down the drain, as long as you get as much as possible into the filter paper. Again, remember to always do a final DI rinse for your test tube. And then some things to remember. You're going through this whole entire procedure with your known solution. You're going to repeat this with your unknown solution. So when you get your unknown solution, make sure you write down your unknown number. You also are going to be given 6 milliliters of your unknown as well, so make sure you save that. Don't use all of it all at once. Remember to start with clean test tubes. The worst thing you could do is start with some dirty test tubes and get some false positives with your unknown right from the beginning. Also remember there are only 4 ions that are present in your unknown. Your known had 9 of them. There are just going to be 4 present in your unknown. So because of that, you don't expect to get the exact same results. There are going to be times when the products won't be formed that were formed for your known solution. So you expect it to be completely different. Other hints. You have 2 things that you should be looking at during this lab. One of them being a detailed lab procedure. You should follow this exactly. And the other one being a flow chart. And the flow chart gives you more of an outline. It shows you the overall look of the procedure. So with your detailed lab procedure, you've got some things like reasoning behind things described. Why is it that these things form precipitates? You've got very specific, I can't really read this here, but in there it tells you very specific concentrations, 6 molar. It tells you how many drops of things, 8 drops. So you're going to go ahead and read through this very carefully. It'll tell you some things like, hey, make sure once you get it to this point, keep adding a drop until you're sure that precipitation is complete. So this tells you detail. This doesn't. All it says is, yep, we're going to be adding some hydrochloric acid to separate these two things. So both of these have their merits, so make sure you follow both of them. And then, as far as confirmation, remember that if you look at your lab procedure, you can read through here, and this is really hard to see, but right here it says something about how this confirms the presence of, I think it's lead ion that it's confirming right there. So it's underlined for you. There should be 9 underlines throughout your lab showing those 9 cations. In your flow chart, you don't see it like that. Instead, you see a boxed and shaded little area where it shows it confirms the substance. So when you get to a point where you have a dead end, there's nothing coming off of here, there's nothing else here, that's that confirmatory test where you don't need that test tube of solution anymore or that precipitate. You're done with it, you can dispose of it, clean out your test tube, use it for a different step. So it's pretty easy to see where that dead end is on the flow chart, a little bit more so than you can in your detailed lab procedure. And then lab write-up. This is one of the last things we'll talk about here. With the lab write-up, it's okay if you don't do this nice and neatly in your lab notebook till the very end. A lot of people will try. It's a good thing to try and keep track of during your lab. So a couple different options for you. And remember, this is required to be turned in at the end of the lab as part of your test grade. So your test grade is identifying all 4 of those ions. On top of that, you need to turn in a lab write-up. And you've got 2 different options for how that lab write-up can look. It can either look like this, which is described in your lab that you have in front of you. And really all you're doing is saying, okay, this is the procedure, and these are the results and the conclusions for your known and the results and conclusions for your unknown. So you can go through this just having multiple parts to this table. That's one possibility. Another possibility is that you can do option 2, which is using a flowchart form. And for your flowchart, you're just going to recreate the flowchart for your known. And with this, you're describing what you see, what colors you see, how you can identify it as that ion. And then you also have to recreate a separate flowchart for your unknown. It will not look like this. It will look a little different because you do not have all 9 of these ions. So for example, it might say there was no yellow precipitate formed. You have no lead. So your flowchart will look a little bit different. And then all of this detailed grading information will be discussed in class. There's going to be a grading rubric, calendar. All that stuff will be found on the website, and you'll have access to all of that as we get closer as well. And then finally, the last thing to remember, and please focus on this, is that this is a fabulous time. This is the end of the year. The workload that you're going to be doing is focused on class time. It's in class. You don't really have homework to do at night. You'll have a lab write-up. Maybe, finally you're going to do it at the very end, but for the most part, you have no homework. This is fun time. You get to use all of that information that you learned throughout the year and do some chemistry. So it will be fun. Enjoy it.